So what is biology? Biology is a study of living systems. You know, rather living systems of plants, ourselves, animals, it's a study of life. So what is microbiology? Well, microbiology is a study of organisms that we cannot see. The only way we can see these organisms is with the microscope. Now, a lot of these organisms are like bacteria, fungi, microarthropods, viruses, or even classified as microbiology. Before we go much further, how big is a bacteria? Well, bacteria can be between 1 to 2 microns in size. Now, to give you some kind of comparison, a human hair is about 70 microns in width. So a bacteria is very, very small. But these little small organisms are extremely critical, not only for our own benefit as humans, but also for our soil's benefit and our animals and our plants. There are as many organisms, microorganisms, in a teaspoon of healthy soil as there are humans on Earth. So why is this microbiology so important? Well, one critical part of microorganisms' abilities are to decay these residues we put on our soil surfaces. To take this immobilized material and remineralize it back into our soils. So basically the biology, the microbiology, is our decomposers. But what's also very interesting, the plant's able to harvest this photosynthesis, energy, sunlight, capture it in its leaves and stems, and use it for its own growth, but also to help feed our soil microbiology. Now that plant needs a lot of that carbon, photosynthesis energy, for its own vegetative growth and to get to a reproductive state, like this plant is doing right now, producing seed. But it also gives up a lot of that carbon, photosynthesis energy, back to these soil microorganisms. But it's not just one-way path. The plant's willing to do that as long as the biology, especially the bacteria and fungal component, are willing to go get out and get the minerals, the nutrients the plant needs. So it's an association. The plant sends out the chemical signals to attract the biology that it needs to feed it the nutrients it wants. That's how the process works. It's called root exudates. The plant sends out the root exudates to wake up the biology within the soil, the microbiology. Then the microbiology goes out and finds the minerals and nutrients the plant needs. In return, once it gives it to the plant gives that microbiology carbon to feed these organisms. These microorganisms are in our soils. So the way the nutrient cycle also works is, think of bacteria, these little micron organisms, 1 to 2 microns in size. They're like little bags of nutrients. Unfortunately, a lot of times those nutrients cannot be released until we have something come along and eat them. That's the reason it's critical to have protozoas, nematodes, microarthropods, earthworms in our soils. It takes something eating something else to help cycle those nutrients back into the soil solution. So the way this cycle kind of works, which is very fascinating, is once we build these residues on our soil surfaces, we go from immobilization into mineralization. But see, it's the biology that does that. The fungal helps break down these cellulistic materials, highly lignified materials, and it sequesters it back into the soil. We can go from immobilization of nutrients, cycling those nutrients through mineralization, through the microbiology, back to our plants. Let's start understanding this a little bit better. It takes solar energy to grow a plant. And that plant's able to capture carbon from the atmosphere, build vegetative growth, but it uses some of that also to feed the microbiology within the soil through these roots. Now let's start talking about a little bit what's occurring in the soil along these roots. These macro aggregates that are being built by our microorganisms. The bacteria build the microaggregates, but it's the fungal that build the macro aggregates. When you get this underneath the microscope and start looking at one of these aggregates, it's pretty amazing. You'll see these fungal strands wrapped all around this aggregate. This is kind of like its own little world here within the soil that's being controlled by these fungal strands. And it's that fungal strand helping make associations with these roots. The plant sending out through its roots the chemical signals to help tell these fungal strands what they need. That fungal strand can control that macroaggregate and kind of make those bacteria do what they want, which is pretty amazing stuff. Not only do we need these aggregates to help infiltrate water into the soils, but we also diffuse oxygen. Now remember also, 78% of our Earth's atmosphere is nitrogen. So is nitrogen really our limiting factor to grow a plant? No, it's building soil aggregation. So what are the three main things? We would take this plant and we would dry it down. 97% of what we'd find in here would be carbon, hydrogen, and oxygen. So everything we need to grow this biomass, we basically get for free. When these plants get to antithesis, reproductive stage, they're no longer pushing root exudates, carbon, into the soil. They need that carbon now in order to reproduce. That's the reason why it's so critical to keep a living root in the soil at all times. Because once this stops pumping carbon, our soil microbiology that's building our soil aggregates is no longer functioning. The plant sends out the chemical signal saying, hey guys, I'm going to reproductive stage. It's time to go to sleep. But as a producer, we know an aggregate only lasts between 21 to 28 days. So if I want to maximize my efficiency, I need to make sure I've always got a living root in the soil feeding carbon to the microbiology. So that's the only way I'm going to build soil aggregation. Now our management has very, very critical in this process. So if we're grazing and we start overgrazing these forages and we graze more than 50% of the biomass off, we'll start sloughing our roots off. So no longer is the plant feeding carbon into the soil. It's trying to take all the carbon it can capture to maintain and repair itself to start growing again to try to get the reproduction. But if we just do 50% or less, our plant's maximizing the amount of carbon it's feeding into the soil. And we can keep this plant at more of a mid-stage maturity. So it's maximizing the amount of carbon that's flowing into the soil. So it's our management that really affects building our aggregate. The things we have to understand as producers is the biology works in a subaquatic environment. It is critical we keep these soil surfaces covered. We don't know when it's going to rain again. We need the microbiology working for us. We need to be growing the living root in order to feed carbon to the microbiology. So we got to have the water, then we got to have the carbon. The reason why carbon is so critical, it's the backbone of life basically. So first thing is, carbon's what makes carbohydrates, carbon's what makes our fats, lipids, carbon is what helps make our proteins, and carbon is also what makes our nucleic acids. So carbon is essential for life. What got me excited about biology was we never put it in this kind of perspective before. You know, growing up in production agriculture, we always treated the soil as an inert system, something that always required inputs being given to it in order to grow a crop. When I discovered mycorrhizal fungi and the association it had with plants, I had never heard that conversation before in my life. So I did my due diligence. I started reading. Come to find out that mycorrhizal was throughout my part of the world, 98% of the grassland. So I started finding out that there's this whole system underneath our feet that we knew nothing about, especially myself as a producer. And the further and further I kept self-educating, the more important it became to me. Just like soil aggregation. Soil aggregation is important because every rain event we have, 2 weeks later, we're praying for another rain. Well, we didn't infiltrate the water we received. 50% of it ran off. So what good does it do to get rain if we can't infiltrate it back into our soils? Our soil should function like a jar of marbles. So when we have rain hit the soil surface, it should infiltrate in. Water was never meant to run off. It was meant to go into aquifers, springs, and be utilized by the plants. And the beautiful part about this is, as producers, we affect this tremendously. These are things that we need in order to grow crops, to grow animals, but also how much we can mitigate things, like flooding events. You know, I live in the Missouri-Mississippi watershed. We just built levees higher and bigger than ever before to control water. Well, we should be controlling this water out here on these landscapes, and we can affect that. All we have to do is keep a living root in the soil, keep our soils covered, build soil aggregation, and hold our water. You know, I always love the expression, manage for what you want, don't manage for what you don't want. And part of what I want is I want to build this microbiology in my system. So in order to manage for that, I've got to follow these principles. So why is diversity important? As we stated earlier, these plants send out chemical signals to the microbiology. But remember, each plant sends out different chemical signals. Mother Nature never grew in a monoculture. She always grew in very high complex diversity of plant species. So there was different plants sending out different signals, root exudates, to feed different microbiology. So that's the reason why it's critical to have diversities within your systems, whether that be a cover crop mix, your perennial grasslands, or woodland structures. These plants have this amazing ability. They have these glues, these biotic glues, all over their stems and their leaves. It captures those organisms in the atmosphere. And they're working along this leaf and along this stem just as well as they're working in our soils. Now, when it goes to reproductive stage or production, that plant's no longer needing any association with this microbiology. So this microbiology will spore up on these leaves, but it's held together by this microscopic biotic glues. The critical thing for us to do as producers is to make sure we get that vegetation down on the soil surface. As we go through seasonal changes, freezing and thawing, these glues break down and these spores fall to the soil surface. So if we get this biomass laid down in the soil, allow these microorganisms to enter into our soil, then we gain more diversity. When we grow plants in diversity, we have healthy soils. We can actually physically change the nutrient density of these plants. We can visually see it. We can see blade structures get wider. We can check it with refractometer. Also, we can measure it physically on tissue sampling. But what's incredible to me in the power of a producer, not only can we infiltrate more water into our landscapes, but we can affect human nutrition. It's just not getting the macronutrients we need for bodies, it's the micronutrients and the biomolecules that are essential for our lives. When we start growing in diversity, we start attracting above ground biology too. We start bringing in butterflies, insects, good beneficials, and sometimes pests also. The nice thing about it is, as I said, these stems and leaves have biotic glues all over them. So every time a butterfly touches this, it's moving biology from this leaf over to another leaf and moving from another leaf to another leaf. So it's helping move a lot of this microorganisms from one plant to another, creating diversity. So it's just someone else coming in here helping me build my system. And the animal impact is critical. That's how these grasslands were built. And if we overgraze, we take all this plant is no longer going to send carbon back into the soil. It's going to need all the carbon it can capture in order to get vegetative growth again. But if we graze properly and only take half the plant and keep that plant at mid-stage maturity, we can keep these plants pumping carbon pretty strong throughout our growing seasons. So this is a very easy process that producers can do going out in their own fields. Taking a shovel, sticking it down in the soil, and pulling back some of that earth. Now, there are several things we like to do when we're looking at soils. We look to see how well the aggregation is in the soil. And as you can see, when we toil this apart, we can see the soil aggregation. We can see the root hairs in the aggregates along some of these root hairs. We can also see wormholes, telling us biology is in there. And in fact, there's an earthworm in this soil. One thing we also like to do, which tells us a lot how well our soils are, or what kind of condition our soils are in, is a sniff test. So when we smell our soil and we get this pungent smell when we smell it, it usually tells us it's an anaerobic state. We're producing things anaerobically, like methane. That tells us a lot what's going on with our soil function. We get this nice earthy smell like this soil smells. We know we got a pretty good fungal component in our soils. We don't want to see platiness, because platiness means as we go a little deeper in the soil, we've got some platiness right here. We don't have the aggregation. So what's going to happen when water infiltrates in? It's going to go through that soil aggregation till it hits that point. And once it hits this point, the water's just going to dissipate and it's going to move laterally throughout the system. It's not going to keep infiltrating down. A plant root can only break about 300 pounds of compaction. But one of these little microscopic fungal strands can break 1,100 pounds of compaction. So what do you want? We want both. We need the roots feeding the microbiology to help build the soil aggregation so we have a better effective rainfall. or better effective water event. I truly feel it takes a crisis in order to create change. When I first started cover cropping, I was doing it just to grow feed for my animals. I knew nothing about what was going on. I took all of it, and we could get away with that because we were in a very humid environment. Well, it finally caught up with me. One year that I took everything, exposed my soil, and it quit raining, I had a crop failure. From that point on, I quit being intentionalish and became intentional. So I'm not saying you don't come out here, if you have a pest issue, you don't go out here and don't control it. If I come out here and I put a seed treatment on, or I come out here with an insecticide, or even sometimes a herbicide, I'm gonna affect this system somehow, some way. And you start developing a consciousness, and you start asking yourself the question, do I really need to do this? Or most often, we encourage people to go out here and test it. Do part of the field and don't do the other part of the field, and see the differences. See if it was beneficial or not. We've got everything we need, we just need to educate ourselves. Mother Nature set the rules. She's got thousands and thousands of years of research and development. We've got a few decades.